In this movie, we'll look at component diagrams and why we might want to use them. First, I'll look at how you might use them to model software components, the interfaces that they provide or require, and the dependencies between them. One of the reasons for using components is to gain the benefits of software reuse, and they're often used to show how existing components will be integrated into a design. Finally, components can be made up of subcomponents, and ultimately are made up of classes. And we can use component diagrams to model how the functionality of the components is delegated to instances of subcomponents or classes. Components are a way of organizing the functionality that will be delivered into clearly defined units. These could be logical components that are determined during analysis and design as a way of structuring the software, or they could be physical components that represent reusable software libraries that are going to be used in a project. Components should be cohesive. That's to say that they provide a clearly defined grouping of functionality that makes sense to be included together. And they should have low coupling, that is, low levels of dependency on other components. Components expose their functionality through interfaces. These could be application programming interfaces, APIs, or they could be something like web services. The principle of information hiding is used to keep the details of the implementation from other classes or components that use the services they provide through interfaces. This approach allows components to be wired together through their interfaces, where the required interface of one component is matched to the provided interface of another component. And these are either shown with dependencies, as at the top of this diagram, or by linking the interfaces together, as between the lower two components in the diagram. The diagram shows a word processor and an email client as components, both dependent on a text editor component through an interface. The text editor, in turn, is dependent on a spell checker through a spell checking interface. Many organizations seek to achieve the benefits of software reuse at the component level. This means that they may have existing libraries of software in the form of components that can be reused in new projects, or they may buy commercial off-the-shelf COTS software, or indeed use open source components. The use of and dependencies on these components can be shown in component diagrams, and the details of the interfaces that they expose to the outside world can be shown as in this diagram. The operations of interfaces can be shown if required. In this example, the home automation system is going to use a pre-existing component to provide communications using the X10 protocol, and the device manager component will access its services through the X10 service interface. Components can be built up of subcomponents, each with a specific cohesive set of responsibilities within the larger component. We can use a composite structure type of component diagram to show the subcomponents within the component, and also the way that the services provided by the interface or interfaces are delegated to instances of those subcomponents, or ultimately to instances of the classes that are compiled into components. In the next couple of movies, we'll look at the notation of component diagrams.